In designing this table, I have two versions that I'll need to produce. SolidWorks has always been very good about giving us the ability to build in different versions or configurations into our parts and assemblies. And that's what I'm going to do here. Let's add a new configuration. Let's call this configuration square. As you might expect, this configuration is going to be square. My design intent is for this to be square. Now, the most powerful way that I can make this table square is actually with an equation. However, with an equation, I've got other configurations that I've got to consider. Well, with SolidWorks 2014, I can actually handle both of these scenarios at once. If we take a look at this dimension, what I really want is for this dimension to equal this dimension. And I can do that. If I set this dimension equal to this dimension, I can now control when that equation takes effect. So for example, I can say this configuration only, and now only this new configuration titled square will contain this equation. We'll say OK and rebuild. As we would expect, we find our table is square. Now, when I return to my original configuration, we will see that this equation is not present, and my table returns to rectangular. Let's take a look at how this works. In Tools, Equations, we will find that we now have an area here that marks which configuration we're working with. So if I change my configuration to square, we will see that that equation that I've written now exists. In rectangular, it does not. Okay, so Tools Equations now stores the differences between configurations. This is very powerful. Weldments are a great tool in SolidWorks, and this year they've been improved for a significantly more intuitive workflow. Let's take a look at this demo I have set up. I have 4 structural members set on a path. We'll notice that they are set in a custom location on the profile, and they're set off at some arbitrary angle. The freedom that we now have with SolidWorks 2014 is we can change these to any size we want and still be able to keep that custom location. I can make these any size, and notice they're still set to this point in the corner. One of the ways it's able to do that this year is through the revamping of the structural system. Let's take a look at how weldments have been improved. In this weldment profile, one thing you'll see in particular, and that is this table. All of our weldment sizes are now built into the same sketch, and because they're all built into the same sketch, that means that each point in that sketch is the same point over and over and over. So no matter what size that weldment becomes, that point is still the same point. You'll also notice that these have been generated with a table. And that also means that you can adjust these using your design table. So we've moved all of the information to one central location for each of these weldment profiles, which makes for a much smoother workflow when working with weldments. This is a very elegant solution for improving how weldments work. Now, earlier we talked about Conex being improved in sketching, and this year we've got some additions to that Conex family. We have now Conex being available in 3 dimensions, and it's really easy to manipulate because they've built Conex into the fillet tool. So the same old fillet tool that we've been used to working with now has more power than ever. If we take a look at this fillet tool, what we can look at here is a constant size fillet. And with this constant size fillet, if I select one of these edges, of course with tangent propagation, that will create a fillet all the way around this top edge. So what I have now is a standard 10mm fillet, but let's take a look at these options. In the fillet parameters, we see that I have a profile option, which is new. And in this profile option, if I expand this out, we have 2 additional options, one being the conic row and one being the conic radius. Now the conic row, the row value, again, as you'll remember, is the angle of the plane as it crosses through that cone. The conic radius just lets you define what the minimum radius of curvature is for this shape. Now let's see what this does for us. If I select conic row, this brings up a value where I can adjust the row value of this conic. You'll see that I'll be able to independently now control both the size and the shape of this fillet. So let's take a look closer so we can see what's happening. And you can see with this low row value, I have near to a chamfer. All right, and by adjusting this, we can see that I can control the shape of this fillet independent of the size. All right, so from something sharper down to something a little bit flatter. If I choose conic radius, we get the same ability to control this with just a different value. All right, so now I'm defining the minimum radius of curvature. So we can see with a smaller minimum radius of curvature, it will sharpen up this fillet. Now notice that the lines haven't moved. The fillet size is still the same, it's just a different shape. All right, so running through those different options of conic shapes. Okay, this is pretty cool. In fact, if I set this to 10, we can see that with a conic radius that equals our fillet radius, that will produce a circular fillet, which makes sense. If our minimum radius of curvature is the same size as all of the other curvature, then that will line up to be a regular circular fillet. Let's see how this applies in other areas of the fillet tool. Take the variable size fillet, for example. If we select some regions on this part, say here, and say here. Let's set this to 10 and 10 for all, and we'll keep this being defined by the conic radius. I like defining my conics this way. We'll set those, which starts us off with just a regular 10 millimeter fillet all the way around, same as where we started. But now I have the freedom to adjust how this actually looks. For example, if I move up to the top, let's say we want this fillet to peel back a little bit so it's a little bit larger, but it gets a little bit sharper. We can do that very easily with the conic fillet tool. I can set this, so I want this to peel back a little further. I'll move this to 15 millimeters. My conic radius I want to reduce to sharpen up this shape a little bit. So let's change this down to, say, 2 millimeters. And by doing this, we can see that my fillet now peels back a little bit more, it's larger in size, and the shape is sharper. So starting from here, where this transitions out, its last point, we now start from a standard fillet and we move up to this sharper new shape. So once I accept this, we can see that we can have a much wider variety of shapes and we can get there significantly quicker with the new conic fillet tool. Let's see another area where this applies. Let's take a look at the face fillet tool. This is a great example of when you might use the conic fillet tool. This area up here is a little bit flat, and what we want to do is transition from this fillet area up to this neck, sort of like a draft. And the conic radius is going to be a great tool for us because once I choose these faces, if I go from this face up to this face, we have the ability to now control both the size and the shape. So let's take a look. If I come down to my fillet parameters, I'm going to define this by my conic radius, again my preferred method. You'll notice that we also have curvature continuous in this drop down. All right, this is just a move in the interface, so that's just shifted to over here. It's the same tool. If I choose conic radius, we can see that this is a great illustration for being able to illustrate those independently. So let's take a look here. If I scroll through the fillet size, we can see that the size of this transition, as we would expect, changes. All right, I'm holding Alt on my keyboard right now to adjust the value that this indexes by. On the other hand, if I look at the conic radius and adjust this value, we can see that we're adjusting the shape rather than the size. So by controlling the two of these values, I can increase this or decrease this and change the shape until I get the transition that I'm looking for. Once I say OK, it creates that blend. So we can see that the fillet has now been packed with even more power than it had before, and we can get to much more complex shapes than the fillet was ever capable of generating in the past.
Hello and welcome to this video on the new sheet metal tools in SolidWorks 2014. Back in SolidWorks 2012, a new powerful sheet metal design tool called sweep flanges was introduced. However, in certain circumstances in previous versions of SolidWorks, cylindrical and conical sweeps could unfold about the wrong edge or path direction. So for example, if we have a sheet metal part like this that was created using sweep flanges, and if we go ahead and flatten this part out, you can clearly see that the unfolded part is incorrect. To rectify this, SolidWorks 2014 now introduces a new option under the sweep flange tool. So if you right click an existing sweep flange tool, you can simply edit feature, and now you will see a box where you can check cylindrical and conical bodies. You can then select an edge to anchor your cylindrical or conical bodies. So for this example, I'm simply going to select this edge, hit the green check mark, and now when I flatten my sheet metal part, you can clearly see this is the correct flat pattern. SolidWorks 2014 has also introduced a new sheet metal tool called the sheet metal gusset. This now allows you to easily create sheet metal gussets by simply selecting two faces where the gusset will be placed. You can see that the tool comes with an array of options which allows you to place the gusset. It allows you to size the gusset correctly. It even allows you to change whether the gusset might be rounded or even a flat gusset. Once you've selected all your options, you can simply hit the green check mark and your gusset will be placed. Now, to place the gusset on the other side, you can simply re-access the tool, select the two faces, and you will see that SolidWorks actually retains all the information that you had selected previously. This allows you to quickly create multiple gussets of the same type in your sheet metal part. Manufacturing sheet metal components often means precise control over corner reliefs. SolidWorks 2014 redefines what it means to create this by allowing you to now define them in context of the form or folded part. So if you navigate under the corners tab up here, you'll be able to find the corner relief tool, which allows you to automatically collect all corners in your sheet metal part. And now you can even specify different reliefs type. So for this example, I'm going to simply set different reliefs type for every corner. We have the option to set rectangular. We have the option for circular. We have an option for a tear corner. And we have an option for a brown corner. You also have the option to set a constant width corner relief. Once I've set all my corners, I hit the green check mark, and you can clearly see how the corner reliefs are created. Another scenario that greatly affects manufacturability is the use of lofted bends, another unique and powerful sheet metal design tool. And though SolidWorks has always enabled us to create this using formed methods, SolidWorks 2014 now provides an option to show this feature in a bend or transitional state. So for example, if we create a lofted bend within these two sketches, we can now specify either to have it as a bend manufacturing method or the previous formed manufacturing method. So if you take a look at the bend manufacturing method, we have an array of options where we could have chord tolerance, number of bends, segment length, and even segment angle. This now gives you better control over your lofted bends for more precise sheet metal bending.
Alright, let's talk a little bit about graphics and rendering. Before we get to any kind of rendering, I want to talk about something that they've added in this year that's a little bit buried, and that would be the ability to save out directly from SolidWorks as a PNG image. And that might not sound like that big of a deal, but what a PNG image stores is actually very useful to us when we're saving things out. Let's take a look. A simple save as will do the trick, so File, Save As. And if I choose my Save As type to a Portable Network Graphics PNG file, in the options of a PNG file, we'll find that there is an option to remove background. And remove background is pretty cool. The way that a PNG image works is that it stores each pixel as a color, and it also has the ability to store each pixel as transparency. That's called the alpha channel. So by saving this out as a PNG image, what that allows us to do is save this with no background, still shaded. Alright, this lets us put that image over top of something complicated in the background and not have to take out any of the white behind it or whatever we would have to do typically in the past. Alright, pull that into Photoshop and start removing things. This is huge for me. I love this new option. SolidWorks 2014 includes many new environments as well. Let's take a look in my environments dropdown. In my list of scenes, we see that I actually have fewer scenes than we normally would see in here. So where are all the new ones? If we look at this new option, they've actually added so many new environments that they ran right off the bottom of the page. So they added in this new Manage Favorites tool, which is pretty neat. If I open up Manage Favorites, what this allows me to do is choose out of this list of environments. Now we can see that there's a lot more than there used to be, and even cooler, if we scroll over here, we can see a preview of what they look like. This is just so we know which one is which. With those checked on, I can choose the ones that I use most often. I can move them up, I can move them down, so I have them in the same order as well. Let's take a look at one of the new ones. Let's use Landscape 4. If I set my environment to Landscape 4, we can see that if I zoom out, we have a pretty neat new environment. Now, as I rotate my model around, we notice that my model doesn't really look like it's existing in this space. My model is sort of moving in front of the environment. In 2014, they've added a new option to help address this issue. If we edit our scene, we have a new checkbox that we have available to us. Flattened Floor is a new option. If I check on Flattened Floor, what this does is it will project the environment up underneath my model. This creates the illusion that my model is actually sitting on the ground. We can of course adjust where the ground hits, where the horizon is, as well as the environment size. If I zoom out a bit, we can see how this works. And this actually works how it always has, we just have a better visualization of it. We can see that the HDR image wraps around our model as if it were on a chrome sphere. However, now the floor can be projected up to imaginary plane to meet the underside of our model. I can adjust again the horizon height and choose where that projection occurs. Somewhere around here. And there we have it. We have another new enhancement to SolidWorks 2014 in the form of environments. If we come over and take a look at our lights, I have the standard 3 lights in this environment. However, if I go to add a new light, we see that we have a new option, and that new option is Add Sunlight. And sunlight is pretty cool. If I click on Add Sunlight, we see my shadow update, but look how we can define this. We can define this by a north direction, a location where we actually are. So right now we're at the SolidWorks office in Boston. We can adjust for time zones, what time of day it is. Let's choose a new north direction. If I choose a new north direction, we can see that that sunlight will update. It gives me the compass rose and my shadow updates as well. Okay, so this is pretty neat. We get an opportunity to take a look at our model actually in its environment. Even cooler, let's take a look at a motion study. With a motion study, we can use the wizard to quickly set up an animation. Now that I have sunlight added in as a light, solar axis study is a new option that I have available to me. If I select Solar Access Study, we get a preview of what we might expect. And this is going to move the light in a way that the sun will actually move. We have a couple of options as to how we want to set this up. We can do a fixed date with a variable time, so moving through the day, or a fixed time with a variable date, so moving through a season. I'll leave it on a fixed date variable time. We can select our date, again choose our time zone, and we can set a range. I'll leave these on the default for now. Set a duration, 10 seconds sounds fine, and hit finish. Once I hit finish, SolidWorks is going through figuring out at that time, at that date, where the sun is going to be and where it needs to move throughout that span of time. And it will set keyframes in the animation for those appropriate locations. And we can see that once it's finished, it will update the background, give us an indication of what time of day it is, and we can see that as I move this, that will update. Let's play through. So we see our shadows updating as the sun moves, as well as the color of the background as the time of day changes. How cool is that?